Hi all, we are going to talk about our project for the ErgoHack. We have been developing our idea about a reputation system, so we will present it on this video. According to Wikipedia, reputation systems are programs or algorithms that allow users to rate each other in online communities in order to build trust through reputation. Trust is the foundation of any functional ecosystem, including the digital world of blockchain. In this space, users must have confidence in the entities they interact with, whether it's smart contracts, addresses, URLs, or other off-chain entities. So why is this necessary? Well, it's necessary because blockchain is based on trust. If we consider that a blockchain ecosystem is enriched by the number of tools it possesses, what value do these tools have if users cannot trust them? How does a user know which ones are available and which are not? How does a user know which contracts, URLs, or whatever else they can use without taking too much risk? The answer is based on what others say. This is so because most of the people who use or talk about Bitcoin don't know very well how Bitcoin works. They haven't read its white paper and much less have analyzed its underlying code. In the same way, most Uniswap users have not analyzed its smart contracts or its web app. They only use them because the people say that are secure systems. To have a good reputation systems, two important parts are needed. The tools and apps of the ecosystem should be open and auditable, and a platform for shared feedback. Because currently, a user decides whether to trust a Web3 page based on what its users say on Twitter or YouTube. This is not peer-to-peer. And this is important because if we eliminate Twitter, YouTube, Discord, and all of these platforms, and if we only stick with a pure peer-to-peer network, does it solve the problem mentioned earlier? Does the average user know which tools are secure and which are not? The response is no. This is where this project aims to help, and we believe that this is a problem that no part of the entire ecosystem is currently addressing. So the main characteristic of this system is that it doesn't require consensus. Alice can trust Bob more than Chris, but Dave can trust Chris more than Bob. This is important because the majority doesn't always have the right answer. Sorry. In order for the system to be adaptable to the user and feel natural, it should allow evaluate things, different ones from others. Therefore, let's say Alice trusts Bob, and Bob claims that Ergo Mixer is safe and works correctly. Alice will trust Ergo Mixer because she trusts Bob. On the other hand, it's Chris who believes that Ergo Mixer is a scam. Dave trusts Chris more than Bob. Consequently, Dave won't have as much trust in Ergo Mixer. However, if over time Chris disappoints Dave, meaning Dave's reputation for Chris decreases, perhaps Ergo Mixer reputation may increase for Dave, and he may start using it. The system consists of reputation of proofs that can be submitted to the Ergo network by any user. In this way, users' opinions about each application, contract, or page, from now on we will call it an object, or about other opinions, are reflected in a distributed, open, and fault-tolerant network. That's Ergo. Each reputation proof has a token used to reflect the amount of reputation that can be assigned. When creating a reputation proof, a user can either generate it from scratch with a new token, extract it from another reputation proof, so the amount of reputation will be extracted for the previous proof. Each reputation proof is a box, and only the users themselves can delegate their reputation from their proofs to new proofs they generate. However, any user can assign a reputation to any reputation proof. That is without transferring the token, simply by locking the value of the proof and then entering the proof to which reputation is being assigned has metadata on the box. On this way, reputation graphs are created. So at the core of our system are reputation trees. These trees serve as hierarchical repositories of trust. With each tree containing a root box representing the 7% of reputation. Within these trees, there are branches and leaves. Branches point to other reputation proofs, creating an hierarchy of trust, while leaves represent reputation proofs assigned to external objects in the form of metadata. This structure provides a systematic and scalable approach to reputation management. For example, on this image, we have 5 reputation proofs. The reputation proof A has been started from scratch, so it has a 7% of token value. The same for the reputation proof E. After that, the reputation proof B and C are created by the same user who creates the proof A. He delegates 20 of the A's tokens for the proof B and 30 for to the proof C. Then the user delegates 5 of the B's tokens to a new proof D. Until now, the user does not assign any reputation to anywhere. That is the operation that makes with the proofs C and D. The proof C assigns his reputation to the proof E, and the proof D assigns his reputation to a Git repository. That's the main idea behind the system. Users can create how many proofs as they want, paying the network fees, obviously, the Ergo network fees. But the value of these proofs will depend on the value assigned to them by other users, a subjective value, and therefore more free and natural. About the proofs spending script, all the proofs have the same script. We kept everything as simple as we could, although reputation proofs can have much more complexity. Each branch of the reputation tree could have its own rules and policies, allowing for customization to meet the unique needs of different communities and contexts. But for now, we want to work only with this. I'm going to explain what do each part of the script. The first condition, the first 2 lines, checks that the proof has not assigned reputation to an object. If it has, the token value was locked because all the reputation is assigned to the object. The second one checks if the user that wants to spend the proof, that is, delegate his reputation, it's the owner. That could be different than the box transaction signer. And finally, the last condition checks that the boxes intending to delegate a reputation are proofs with the same logic as the current one. As a user interface, we have developed a simple form to be able to generate new proofs. As you can see, it allows you to choose between generating a proof from scratch, where a new token will be minted to represent the reputation, and the option to assign it directly to an object, to assign all the reputation directly to one object. On the other hand, the user can also generate a proof by delegating reputation, that is, tokens, from an existing proof. In this way, the user will choose an amount of tokens not exceeding the available total of the proof, and if desired, can assign the reputation from the proof, the proof to generate, to an external object. The next logical phase is a web visualization of the reputation proof owned by the user, as well as the proofs added by other users, so that it's possible to follow users, or in other words, assign reputation to other proofs, to the other users' proofs. We developed the logic for connection and transaction creation from the browser using the Fleet library, but unfortunately we were unable to develop it to display a live test. The Ofin Code has not been developed yet. This code will be responsible for calculating the reputation of a specific item in the user's reputation graph. As can be observed, the user has generated 4 reputation proofs, 2 of which originate from the root of the tree, meaning they minted a new token and initially held 7% of their reputation. The user rates one root proof with a score of 6 and the other with a score of 4. The proof that is rated 6 assigns 20% of its reputation to one proof, which has not been used yet, and 10% to another proof. The latter assigns its reputation to ErgoMixer. Therefore, the value of ErgoMixer will be 10% of the root proof, which is 6% according to the user's perspective. From the other side, the proof assigns its reputation to an external proof, which in turn assigns reputation to ErgoMixer. Therefore, all the root proofs reputation is allocated to ErgoMixer. In this way, the total reputation of the user assigned to ErgoMixer is 46%. The quantity of tokens of the external proof may not be necessary to know for this analysis. However, it's important to examine its code, as the current script does not require the delegation to another proof to have the same spending script, the Ergo script. This means that the delegation process to ErgoMixer can occur with potentially varying amounts, making the specific token quantity less relevant for this reputation assignment. One possible avenue of development is the design and implementation of bots responsible for managing the proofs, with different configurations for different proofs of the tree, and with different agents competing between them, could enable a model of natural selection that, at least to me, seems quite interesting. During the days of development, we didn't have the time and the health condition we would have liked to have in order to develop this idea. Nevertheless, we had a great time. We are looking forward to continuing the project and coming up with some new ideas for the next ErgoHack. Thanks for watching, and any feedback is well received.